I don't know if everybody was here last time I presented. I'm Tom. I'm a senior double E, and I've been working on a project that I'm calling LaForge. It listens to the radio and writes down what it hears. Basic premise is a lot of independent radio stations and even commercial radio stations, most notably our own WRPI, have to maintain playlist logs in order to maintain their license with BMI, ASCAP, or CSAC in order to continue to play music that has copyrights carried through those licensing organizations. And their current system involves writing that on 8 sheets of paper, which doesn't work real great. So I've been working on this for the semester, and things have gone really well for the most part, with the exception of one pretty big bug that I'm going to talk about in a second. First and foremost, I found out that the library I was working with, the LibOFA library, was very intolerant of partial song files. It really wants to have the whole thing. So I had to have my program actually figure out where songs started and ended, which can be a little bit tricky with radio crossfades, songs that start and end at strange places, songs that are continuously played into the next song, that sort of thing. So I integrated a way to deal with that. In the process, I had to set up multiprocessing. I've never written a multiprocessing program before. I'm a Comp Sci 1 background guy with double E experience. I can wire things, but a lot of the programming side of things is very, very new to me. It's not integrated particularly. So this was really a major foray into designing for a piece of software for an actual computer instead of an Arduino. And I'm really happy to say that that's working. Implemented a basic command line interface that can actually control some of the parameters that are used in listening to the broadcast stream. And the whole thing's working all together now, with the exception of the LibOFA library that I was banking on to hand me the critical information. The way this is going to work is you get your audio file, you generate what's known as a fingerprint through LibOFA. It's the Open Fingerprint Architecture Library. And then through that fingerprint, what you get is a portable unique identifier, or PUID. PUID, you can take and query the open source Music Brains database. That's the same one that the card tagger uses. And from there, you get all your metadata, track name, artist name, so on and so forth. You can log that all in the CSV, save the WRPI music director a lot of work. LibOFA is not giving me fingerprints the way I want it to, and we'll see why in a second, or what I think is why in a second. So first we were having some trouble with time resolution. My original strategy was take a segment every 10 seconds, 15 seconds, maybe 30 seconds, and hopefully LibOFA was going to give me my fingerprints from that, because the documentation didn't say that it wouldn't work. It said I needed 10 seconds, so I was going to give it a bit more and pat myself on the back for being so lenient. LibOFA is not that tolerant. It's actually very, very picky about how much of the song you give it. The most I've ever been able to take out of a song and still successfully get a fingerprint is 15 seconds out of a 3-minute track. So what I had to do instead was implement kind of a rotating buffer. So it'll pick up from the stream a segment that has 1 pause in it, a segment that has 2 pauses in it, and a segment that has 0 pauses in it. And by rotating through those, I very rarely miss a song. Over here we have 3 songs stuck together. This is Blink-182's Down. This is a mono mix and stereo mix here. This is Magnetic Fields, a track called Punk Love. Side note, if you're ever going to listen to a song over and over and over again to test something, do not choose Punk Love by the Magnetic Fields. And then the whole rest of this is obsolete by Math, which has 2 pauses in it. So we can see kind of how the buffers are breaking it down and finding the files right now. And this has been, I've tested this and this is working right. You can see the buffer with 2 silences in it, or 2 quiet spots in it to pick off the Blink-182 song. The 0 silence buffer grabs the magnetic fields, and we go back up to the 2 silence buffer to get our mute map track at the end. So that's working really well. And I can go ahead and pull out the temp files that I'm making and listen, and we're getting almost exactly the original file. And I tried it 2 different ways. So far, the first way I tried it, I've only got a microphone input for my laptop, so I tried just the left channel from the stereo mix. Got the file just right, no fingerprints from LibOFA. So I figured, okay, maybe we're not getting the full spectral image here, we'll just mix it down to mono and see if I can get it that way. So did a mono mix down, fed it back through, still no fingerprints. So that's kind of where I am now. And what I'm banking on in order for LibOFA to work, this is really the last straw, is I added the option for 2-channel input. So if you've got a stereo line in jack, and I have to test this on one of WRPI's PCs because I don't have that hardware. But with the stereo line in jack, I should be able to get an exact copy of the original audio file. And if for whatever reason LibOFA can't fingerprint that, then there's some voodoo magic at work that I am not seeing and need to look closer at. But it's been much more picky than I originally anticipated, and much more picky than tests or documentation would have suggested. So that's where we stand for the project. Here's where we are for me. This semester was huge. I've been applying for master's programs in EE, and this has really been the thing that's pushed me to say, you know what, I want my master's in comp sci. This has been really fascinating for me. So I've learned a whole bunch of stuff. How Grace Note actually works. I always figured it was something about lengths on the album, and they were doing some sort of, I don't know, it was magic. So now we know how that works. Got much more comfortable with Python. Multiprocessing in pipes, new, totally new, really fun. Made a fork bomb, sent it to my mother. Wow. So it's a good thing I'm not moving home when I graduate. Definitely the importance of using well-documented libraries. The Python bindings for LibOFA are horribly undocumented, and I hurt a lot because of that. It took a lot of time. Poor Tim Horton helped me debug a lot of things that really should have taken either one of us half an hour, but instead took us both 4 hours, and we went, oh, well, they're throwing these exceptions, but they're not actually printing them to the screen. Why are they doing that? And I'm not quite so much of a Linux tourist anymore. I think now I'm just more of a greenhorn. So it's been fun. It's been really a great thing for me. And I just wanted to say thanks to all of you, especially to Tim. He's spent the time to get me through a lot of nonsense that I shouldn't have gotten myself into. And of course to Sean O'Sullivan, Morthy for taking a chance on an uneducated EE, working with comp sci, and all of you for really teaching me so much with all your projects this semester. Thank you very much.
Questions?
Yeah.
How does Grace Note work, actually?
Okay, so it's actually querying the music IP service, which is what LibOFA does. It'll go through your tracks, and it looks at each file, makes a fingerprint out of it, fires it off to music IP, and I believe that they use their own independent database instead of the open source Music Brains database. But there's plenty of implementations that are out there that use the same Music Brains database, and the strategy is the same. You get a PUID and get metadata from that from an online service. So, yeah.
You know how there used to be an iPhone app which will listen to a segment of music and tells what music it plays. Do you know how that works?
Yeah, I think the basic premise that works with all of them is they go through the file, and all of the libraries require fast Fourier transform. So I think what they're doing is they're getting a power spectral density plot, and then they send that power spectral density plot or some truncated portion of it back up and do correlation and see how close of a correlation coefficient you can get with the original PSD for the original file. Probably done high-res lossless file, and if they get good correlation, they'll send you back a score and some metadata to see if that's your file. I think that's how the iPhone and like Verizon has one, and Shazam and all that. I think that's how they're all pretty much getting it done.
So is this system meant to be used by like a radio DJ or someone who's listening to it?
By the radio DJ. The reason being is every day they're going to have a CSV file that has timestamps for every song they played, track, artist, album. It's all got to be in there, and then it's all got to go out to BMI and ASCAP at the end of the month. So this would just, they could run it in the background, and it would just listen to the radio all day, and if they had some talk show on there, it would just make nothing and log nothing until they heard music.
I was thinking it would be interesting to see like when they play a song, just have it log the song.
Yeah, it could be kind of fun, because we have people call up all the time, and they're like, can you send me your playlist? So if it's open source and people can get at it, there's really no reason that somebody listening to the radio couldn't run it at home either. Anybody else? Do you have a question?
Someone brought it up. Someone asked it last time. Why are you listening to the radio to log instead of just logging when it comes up? Like if you have I don't know what kind of media player you play on the radio, could you extend that?
Yeah, well, that's where the trouble comes in. A lot of your clear channel stations play everything off one. They've got a media player and they just queue things up from a database in Texas somewhere. But a lot of independent radio stations, and that's where the target audience comes in. They'll play stuff right off vinyl, cassette tapes, all kinds of stuff. So I really the most unified way to figure out what's going through is to have one audio feed coming off the board right before we go to the air chain, the pre-processing, because you don't know whether they're going to play a record or plug something into the aux jack or play a CD on one of the 4 CD players or what. So that's why that got implemented.
Most of the time, that's how WRPA operates. They have even final records and so on.
Yeah, yeah.
It's a whole record.
We're pretty arrogant about it too, actually.
I call it arrogance.
All right. Thanks everybody.